Hello friends, welcome back to the Tech Mind Master. Today let's talk about a common issue that can experience by a Spring Boot developer, that is a circular dependency. Imagine two friends, Arjun and Mira. Arjun says, I will talk if Mira talk first. Mira says, I will talk if Arjun talk first. So neither of them talk. They are stuck. That is exactly what happens in a circular dependency. Spring tries to create and connect everything automatically during the startup. But with circular dependency, it gets stuck in a loop. Just like our two friends who won't speak first. There are many ways to fix it and that we will see in today's video. So let's get started.
In Spring Boot, a circular dependency happens when two or more beans depend on each other directly or indirectly, forming a cycle. Here is a basic example. Class A needs class B and class B also needs a class A. When Spring tries to create these beans, it gets stuck because neither can be created without the other. Spring ends up in a loop trying to resolve this dependency, but it never finishes. That is called the circular dependency. Let's simplify it even more. Imagine Anna and Ben, two friends. Anna says, I will only talk if Ben talk first. Ben says, I will only talk if Anna talk first. Neither of them say a word. They both wait forever. So if nobody will speak, that means it will go in a deadlock condition. That is exactly what happens in the Spring Boot with circular dependency. Spring keeps waiting and your app failed to start. Avoid circular dependency to keep your Spring Boot app clean, maintainable, and easy to start. Think before writing class together. Sometimes Spring finds itself stuck in a loop. For example, class A needs class B, but class B also needs class A. Spring tried to create A, but it needs B, so it tries for B, which again needs A. This endless cycle is called a circular dependency. This often leads to a frustrating error known as the bean currently in creation exceptions. Here we can see sample code and error due for it. When Spring trying to create this bean at startup, it does not know where to begin. It start creating class A, but then sees it needs class B. So it start class B, which is turn needs class A again, and so on. Since Spring cannot complete the dependency chain, it give up and throw a bean currently in creation exception. This is a Spring way of telling you, hey, I cannot finish creating this bin because it is stuck waiting on itself. When you run a Spring Boot application, Spring creates something called a application context. Think of this as a Gantt factory that build and manage all the bin, your service, controller, repository, and so on. When Spring detects this circular reference during the context creation, it throw an error called bean currently in creation exceptions. This error means your application won't even start. You will be starting at your console wondering what went wrong. It is frustrating and it eats up your time, especially if you are not familiar with how Spring manages its bins. When you build a Spring Boot application, Spring manages all your classes and wires them together automatically. This is called a dependency injection. But sometimes two beans depend on each other either directly or through other beans, and this can cause a circular dependency. There are different ways to resolve the circular dependency. The first way is use lazy annotation to delay the creation of one of the bin until it actually needed. The second way is use setter injection instead of the constructor injection. As constructor injection force Spring to resolve all dependency upfront, but setter injection gives Spring more flexibility to wire things in stage. The third way is the refactor your code. Before writing the code, ask yourself, do these classes really need to depend on each other? The lazy annotation tells Spring, hey, don't create or inject this bin right away. Just wait until it is actually needed. Then create it. This is called lazy initialization. This breaks the circular dependency at a startup because Spring is no longer required to inject both the bin immediately. It can create one, postpone the other, and resolve the cycle just in time. Now there can be a different scenario for using the at the rate lazy annotations. Use at the rate lazy annotations when first you have a legitimate circular dependency that cannot easily be refactored. Second, one dependency is used rarely or conditionally. Third, you want to avoid restructuring your code but need a quick and safe fix. Now, avoid using at the lazy annotation if first it hides poor design, it causes confusion or make debugging harder, and the last one you use it everywhere instead of fixing tight coupling. With constructor injection, Spring has no flexibility. It must fully resolve all dependent right away. But with the setter injection, Spring can create the bin first even with unresolved dependency, then set the dependent bin later, and breaking the circular loop without throwing an error. In this example, now Spring can initiate class A and class B without needing their dependency immediately, wiring them afterward using the setter method. This break the circular dependency cleanly and allow the application to start successfully. We should use set injection when first you encounter a circular dependency with construct injection. Second, one dependency is optional or not needed immediately. Third, you want more flexible bin configurations. However, we should avoid it if first, your bin must have the dependency to function correctly. Second, you rely on the dependency being final or immutable. Sometimes the best solution to circular dependency is not using at that lazy notation or a setter injection. It is a rethinking your design. That means refactoring your code to eliminate the circular dependency entirely. Because circular dependency are often symptoms of poor or tight coupling between the classes. Refactoring means improve the structure of your code without changing its behavior. In the case of circular dependency, it often means splitting responsibility more clearly, extracting shared logic, and the last one, introducing a new service or utility class that act as a neutral helper. We can use refactor when two classes are tightly coupled and cannot be separated easily with annotation, and their dependency feel forced or artificially, or they perform overlapping responsibilities. However, do not refactor just to avoid one of dependency. Only do this when there is a clear overlap or shared purpose.